Excuse me. Hi guys. So today, as you can see, we're talking about factors, prime numbers, and prime factors. So what are factors? Factors are numbers that can divide other numbers. Any number at all. It could be one. One is a factor of all numbers. So what are factors? Factors are numbers that can divide other numbers without a remainder. Without a remainder. So for example, I say 1 is a factor of all numbers. So any number I put here, 1 must come first. What are the numbers that can divide 4 without a remainder? I go 1, 2, and 4. What I mean is that if I have 4 apples, right, I can use 1. I can put them in groups of 1 without it being left with anything. I have a group of 4 things. I put them 1 for you, 1 for me, 1 for your brother and your sister. It's not going to remain. And then if I have still have the 4 apples, I go, you and I are going to share it. 2, 2, right? Or rather, we're going to share it. We don't know how many. You take 1, I take 1. You take 1, I take 1. That means 2, 2, right? Okay, group of 2. And then 4 can divide itself. I say, okay, the 4 apples are just for me. There's not going to be anything left. Do you understand that? So for the factors are for 1, 2, and 4. The factors of 6, 1, yes, 2. If you want to be sharp, right, when you look at your times table in your head, 2 multiplied by 3, 6, 3 multiplied by 2, you'll be able to know that. So 3 and 6. As you can see, 1 is coming in all of these numbers. Why? Because 1 is a factor of all numbers. And the number we are talking about is still a factor of itself. For every number on earth, 1 and itself is always a factor. Although there are special numbers, we're going to get there, but every number, 10, at the end of the day, 10 can divide 10, 1 can divide 10. 9, 1 can divide 9, 9 can divide 9. Do you understand that? Alright, so that is that. Now let's go to prime numbers, or let's do another one, 21. 1 is a factor. How do I know? Now, how do I know that 2 cannot divide this number? Any number that ends with 0, 2, 4, 6, and 8. Any number that ends with any of these 5 numbers, you are sure that 2 can divide them. So that's why I know that 2 cannot divide this one, right? How do I know that? Okay, what's the next number that can divide 21? We have 3, we have 7, and we have 21 itself. Do you understand that? How do I even know that 3 can divide this guy? If I add the guys together, 2 plus 1, 3. Can 3 go in 3 without a remainder? Yes. So yes, I know 3 is a factor here. Do you understand that? With the understanding of your multiplication table, you'll be able to, get a hold of this. So yeah. So now we're looking at prime numbers, right? Prime factors, rather. But before we talk about prime factors, we've already established that what factors are. Now, what are prime numbers? Prime numbers are numbers with only just 2 factors, only just 2 divisors. Okay, so we have 2. 1 do not qualify because 1, we can say 1 can divide 1 and itself. So 2, my prime numbers 3, 5, 7, 9, 11. No. 9 is not part of the prime number because 9 has 3, 1, 3, and 9. 3 factors, so it's not going to be part of a prime number. Alright, so that's my bad there. So 7, 11, 13, 17, 19, 23. You can go on and on and on and on. Alright, so those are prime numbers. Prime numbers are numbers that have only two divisors or devices. Okay. All right, so now these are prime numbers. Now what are prime factors? They are factors that are just prime numbers. Okay, so we cannot say 4 is a prime factor. It cannot be a prime factor because 3 things can go in 4: 1, 2, and 4. So 4 cannot be a prime factor. All right, so now for you to get, okay, so for instance, I'm trying to get my let's say 12, right? On a normal day, I'm trying to do my factor. to do 12. I go with 1, I go with 2, I go with 3, I go with 4, 6, and 12. These are my numbers, the factors, ordinary factors that can divide 12. But when it comes to prime numbers, these are not prime numbers. These are not all prime numbers. So we can't say these are prime factors of 12. Do you understand that? So that leads us to my point of factorization. All right, I love factorizations a lot. So if I'm going to do 12 as a prime factor, I want to get what are the prime factors of 12. I go 12, and what is the list of the prime numbers that can go in 12? Of course, you must do the list first. 2 is here, you're sure 2 can divide 2, so yes, 2. How many times 2 in 12? 6. 2 can still go 3. Now that we have 3, what is the next number? Of course, 3. Alright, and 1. You got 1 here, so the prime number, the prime factor for 12 is 2 multiplied by 2 multiplied by 3. Even though the ordinary factors of 12 are this, the prime factors of 12 are this. Do you understand? 2 multiplied by 2, 4. 4 times 3, and 2. That's 12. Alright, now let's go for 20. 20. Alright? The prime ordinary factor of 20, let's go 1, 2, 4, 5, 10, and 20, right? These are the numbers. These are the factors that can divide 20. But if someone tells you, find me the prime factors of 20, you're not going to just list all of this. So you go 20. What is the least number, least prime number that can go in 20? What is the least? Of course, it ends in with a 0. I say if it ends with any of these, 2 can go. So you put a 2 there to divide. 2 into 1, 2 in 0. 2 again, 2 in 10, 5. Now that we have 5 here, what is another prime number? Of course, 3 cannot go without a remainder. So the next is 5. 5 in 5, 1. Do you understand? So the prime factor for 20 is 2 multiplied by 2 multiplied by 5. If you multiply everything together, you're going to get 20. Do you understand that? Do you get it? All right. So now let's go on to do prime factors of, we can go on and on. Anything you want to do, okay? So we can do, say, prime factor of 50, right? All right, 50. Of course, it's ending with a 0, so 2 can go, right? 2 in 50, 2 in 2, 2 in 5, 2, remaining 1, 2 in 10, 5. What is the other number that can go? If you're sure, you want to be sure if 3 can go in this guy, 2 plus 5 is 7. 7 cannot divide. You can't get groups of 3 in 7, okay? So the next one is 5. 5 in 25, 5. 5 again, 1. Do you understand? So we have 2 multiplied by 5 multiplied by 5, which equals to 50. Alright? But if you're going to do ordinary factors of 50, the list is endless. 1, 2, 4. No, 4 cannot go. 1, 2, 5, 10. Do you understand? Like that, 25 and 50. But for prime factor, it has to be numbers. These numbers that are prime numbers a lot. Do you understand that? So that's that. I hope you've been able to learn 1 or 2 things today of what factors are, prime numbers are, and what prime factors are, and how to find your prime factors. Now we want to go on to common factors. All right, common factors. I'm sure you've seen, all of you, you've seen questions where you've been asked, what is the prime factor, or rather, what is the common factor between this, and this? Find the H.C.F between this and this. Do you understand? So now we're saying common factors. All right? Common factors. Let's say between 12 and 8, or 8 and 12. between 8 and 12. We're trying to get the common factor, okay? So we can go the first way of finding factor 1, 2, 4, and 8. And this guy 1, 2, 3, 4, 6, and 12, right? What's something that is common? Common factors. What is a factor here that is common to both of them? 1 is common, 2 is common, 4 is common. Is that it? Okay, so now what is the highest? H.C.F. What is the highest common factor here? This is the highest. 4 is the highest, and that's it. Okay, but there's another way you can do it, just like we did our factors, our prime factors, using the other one. So we can go 8 and we can go 12, right? If you're looking for the H.C.F. And then you go, what is the least number? Now, for prime factor, for common factors, if you want to find the highest common factor, something is very peculiar. Until you get to something, they said common. It must be common to both of them. And if we have 4 numbers here, it must be common to 4 of them. All right? So what is the number, the least number, out of all of those numbers we listed, that can divide any of this? It ends with 8 and 2. So of course 2 can go, right? 2 in 8, 4, 2 here, 6. Of course 2 can go again. 2 in 4, excuse me. 2 in 4, 2. 2 in 6, 3. Now we have 2 and 3 here. Nothing else can go. Nothing else can go in both of them apart from 1. And we're not going to use 1, all right? Okay, so what we have, the obtainable is 2 multiplied by 2 equals to what? 4. And that's it. If you can check properly, what we get here is the same thing we got here. So if you can use this method. And if you can, you use this method. But this method is quite faster and easier. When you get to somewhere that what you get, nothing can divide both of them, nothing is common, no factor is common to both of them, you put a stop to it, and that will be your H.C.F. So the H.C.F of 8 and 12 is 4. So that's it. I hope you've been able to learn 1 or 2 things today. I'll see you guys in my next video. Have a great day. Bye.